Hello again, Math 10Cs. In today's lesson, we're going to talk about what the domain and range of a graph represent. Before we get into that, though, I'm just going to quickly review something all the way back from the very first unit of study in the course, because we're going to need to make use of this when we try to properly define what the domain and range of a specific graph is. And the thing I just want to go back to quickly is just identifying some of the number sets that we talked about in the very first unit of the course. One number set we have is referred to as our natural numbers. And we use just a capital N to represent the natural numbers. And natural numbers, we can show them as being numbers that are positive whole numbers. So 1, 2, 3, and so on. Okay, those are my natural numbers. We also have whole numbers. Use a W to represent that. And whole numbers would include all natural numbers along with 0. So it would just be 0, 1, 2, 3, etc. We also have our integers. Integers are positive and negative whole numbers and 0. So if I wrote down a few examples of some integers, so we could start, for example, like -3, then go to -2, then -1, then 0, then +1, +2, +3, and the dot, dot, dots just means so on past that point. We also have our real numbers. There are rational numbers, which are just numbers you can put into a fraction, but we're not going to need to worry about that. We also have our real numbers, and real numbers are pretty much just any number. Any number, it can be positive, negative, it can be 0, it can be whole, but it also incorporates decimal numbers. Okay, so I'll put down includes decimal numbers, because the natural, whole, and integers only have whole numbers. And like I said, we'll need to make use of this pretty quick. But let's start off just by quickly reviewing what we talked about last time, which is determining x and y intercepts of a graph. So we have the x-intercept of a graph of a relation has a blank coordinate with a value of 0. Well, an x-coordinate is when y is equal to 0. So it has a y-coordinate with a value of 0. Your y-intercepts have all of x coordinates of 0. So the y-intercept of a graph, a relation, has an x-coordinate with a value of 0. But our focus is going to be on something called the domain and range of a graph. So we'll start off with some definitions. The domain of a relation is the set of all possible values which can be used for the input of the independent variable. So what that basically means is your domain represents all x values that are on your graph. The range of a relation is a set of all possible values of the output of the dependent variable y. So the range of a graph represents all the different possible y values that exist on the graph you're looking at. Now, I realize just giving a definition like this does not properly define what domain and range are, because what we really need to do is we need to see a picture to make the connection between the graph and what the domain and range are going to be. We will abbreviate domain with capital D, and we will abbreviate range with capital R. So let's go down to the example and try to make sense of this. Okay, so it says list the domain and range for the following sets of ordered pairs. Now, what I said is the domain represents all possible x values for whatever relationship you're looking at. So if I look at these ordered pairs, these values 1, 0, 3, 5, -3, those are all of my possible input or my x values. So the way I would write down what the domain would be is, first of all, I'll write down capital D for domain. And then I'm going to write down these funky brackets. And then what I'm going to do is I'm going to list the x values from smallest to biggest. So if I look at all my possible x values, my smallest x value is -3. Then in an increasing order, it'd be 0, then 1, then 3, and then 5. Your range represents all of the possible output or y values in a particular relation. So if you look at these are all my possible output values: 2, 5, 8, 9, 2 again. And what I want to do for the range, which is all my possible y values, is again write them in ascending numerical order. Now, I should point out that 2 repeats twice. So we do not need to write down 2 separate times. We just write it down a single time. So you write down 2. Then what's the next biggest number? Actually, 2 is not the, the next biggest y value would be a 5. And the next biggest y value would be an 8. And the next biggest y value would be a 9. Okay, so the domain represents all possible x values in your relation, and the range represents all possible y values in the relation. So we can also do it for this next one. So what are all the possible x values? We have 3, we have 0, we have -3, we have 2, and we have -8. So I'll write down D for domain, and this would be equal to, use this squiggly bracket, and write it in ascending order. So your smallest x value would be -8. And then we would have -3. And then we would have 0. Then 2. And then 3. Domain is all possible x values or input values in a relation. Now your range, let's look at all the possible output values. You have 3, you have 3, you have 3, you have 9, and you have 3. If any of these numbers repeat, you do not need to write them down multiple times. So here the 3 does repeat 4 times. We're just going to write it down once. So all my possible output values would be in this relation, whether it be 3 or it's going to be 9. And that defines what the range is. That's how we can do this from a given set of ordered pairs. Now let's look at this graphically. Okay, so the second example, I have a bunch of points that are on a Cartesian plane, and I want to identify the domain and the range. Okay, so let's do the domain first here. So the domain would be equal to, so the domain represents all of your possible input x values. Okay, so what possible input values do we have? Well, it looks like we start at x equals -4, and we go all the way up to +4. So my possible input x values would be -4, -3, -2, -1, 0, and then 1, 2, 3, and then 4. So domain is all possible input values in my relationship. Your range would be all of your possible y values. So we look at the y coordinates of these points. Okay, so what's the smallest y coordinate you could have? Well, when you're on the x-axis, so that would be here. So here you would have your this point, you would have a range of the y value here would be 0. Then the y value goes up to 1. Then the y value goes up to 2. Then the y value goes up to 3. Then the y value goes up to 4. Now, after that, you just repeat the same y values again. You go 4, 3, 2, 4, 3, 2, 1, and 0. So we don't need to rewrite those out again. So I can just simply close off the bracket now because no repeats. So far, not so bad. Your domain is just all possible x values in a relationship, and your range is all possible y values. Now, B is where it's going to get a bit trickier to write down what the domain and the range are going to be. So in this relationship, I'm starting at x equals -4, and I'm going all the way up to x equals +4. But the difference here is that this line is continuous all the way from -4 to +4. So you would have numbers like -3.5, or you'd have like 2.1. Like you'd have every possible number going all the way from -4 to +4. There's no way we can write it down in this format here. We'd have to write down like d equals -4, then d equals -3.99999, then like -3.99998. Like that is not by any means an efficient, well, you can't do it. It'd be impossible to actually like write down all possible x values like that. So we're gonna have to do it a little bit differently. And this is where it's gonna look a little bit strange in terms of how we write this. So kind of bear with me for a moment. Okay, so let's write down the domain is going to be equal to. Now, if I look at the graph here, here's what I know. I know that of all of my x values, they have to fit in between -4 and +4. So I need some way just to write that down. So the way I would write this down is I would write down all of your x values have to be greater than or equal to -4. So I'm going to write down x must be greater than or equal to -4. Okay, so what this means here is all of your input values have to be at -4 and they have to be bigger than that. Now, I couldn't leave it like this because the problem is if I say x is greater than or equal to -4, then my graph could have x values of like 5, 6, 7, 8, etc., which is not correct. Okay, so you actually need to put another restriction on the very this end of the graph as well. So I also know that all of your x values must be less than or equal to 4. So what I'm going to do now is I'm going to write down less than or equal to 4. Now, if you look at this, what I would do is kind of like look at it in two different parts. So in the first part, I would just I start the x and then look to the left and identify what it says. So it would say x is greater than or equal to -4. Okay, that defines kind of like the lower limit in a way. Then I would start at x and look at the right-hand side, and then I would say x is less than or equal to +4, which identifies the upper limit for all the x values you can have. Now, between x is -4 and +4, which kind of numbers can you have? So let's go back up to our number sets here. Are the numbers in that between -4 and +4 only natural numbers, whole numbers, integers, or real numbers, which can include everything like decimals? Well, it should be real numbers. Okay, everything in this range from -4 to +4, I can have decimal numbers. So what I'm going to do is after the comma, I'm going to write down x. Then I'm going to write down this weird little like E symbol, and I'm going to write down capital R. What that means is x is any real number. Okay, so my domain is being defined as x is bigger than or equal to -4, it's less than or equal to +4, and in that area from -4 to +4, x can be any real number. Okay, let's look at the range now. Okay, so we use capital R for range. Typically what you do is you're looking at a graph that's continuous. I would look at where is going to be the smallest y value and where is going to be the biggest y value. So the smallest y value in this graph would be 0. Okay, so this means that y has to be greater than or equal to 0. So I'll write down y, and y must be greater than or equal to 0. Then I would identify what's the biggest y value you can have, which is the very top right here. So at the very top, I would have your y must be less than or equal to 4 at the very top. So what this means here is it means I'd start off by looking at the y and then look to the left-hand side. So then I would say y is greater than or equal to 0, which it is. And then I'd start at y and look at the right-hand side where it says y is less than or equal to 4. So the left-hand side is you identifying your lower limit on the y values, and then the right-hand side is you identifying your upper limit on the y values. Now from 0 to 4, what kind of numbers can we have? Well, all numbers, okay, including decimals. Therefore, I'd write down y, and that little e symbol just means is. Y can be any real number. Okay, let's go over to this one. Now, if you have a line with an arrow on it, it just means that this keeps going on forever. Okay, it just means it keeps going on forever. So let's identify our domain here. Now, which x values are allowed? Well, if this line keeps going on forever towards the left, and this line keeps going on forever towards the right, it means that you'd actually have x values starting at negative infinity and going all the way to positive infinity. So actually, your domain can be any real number. There's no upper and lower limit here. We can just say the domain, that's supposed to be a squiggly bracket there. Your domain is x is any real number. So any real number is allowed. Now for the range, now this graph keeps going on forever. So your y values, you're going to have like increasing negative y values. You still have a restriction on the upper limit here. Okay, no matter what you do, you cannot get above positive 4. So what we could do in terms of defining the range is we could just say the range of the graph is all y values that are less than or equal to 4. So we could say y is less than or equal to 4. Just note the difference between this graph and C and B. So in B, the graph actually stops at the x-axis. Here, the line keeps going on forever. So this means y less than or equal to 4 is okay. Those y values are going to be on the graph. And we can clarify a bit more about the y values. Like, what are the y values? Natural numbers, whole numbers, integers? Well, as long as we're less than or equal to negative 4, y can be any real number. So that's what the domain is. The domain is like just a way of listing all possible x values in the relationship or the graph. And the range is a way of listing all possible y values for your relationship or for your graph. Okay, let's go to the next page. Okay, so it says state the domain and range of the following relationships. Okay, so this top one, again, the arrows mean this keeps going on forever. Okay, so let's start off with the domain. So which x values are allowed? Well, if the graph keeps going on forever towards the left and forever towards the right, then we can have an infinite number of x values starting at negative infinity and going to positive infinity. Therefore, I could say x is any real number. So all real numbers with no restriction are allowed for this graph. For the range, you got to be a bit more careful, okay? Because the graph, no matter what you do, you can't go below this point, okay? So this point is where y would be equal to -1, -2, -3. So what I'd want to do for the range is I would say the range is equal to, basically the graph has to be greater than or equal to -3. So I could write down y is greater than or equal to -3. And if the y values are greater than or equal to -3, what kind of y values are allowed? Well, any real number, as long as it is greater than or equal to -3. Okay, let's look at this next one. Okay, so this one, if you look at the x values, this is an oval shape. So on the left-hand side, it looks like we go from -2 all the way up to +4. So we're going to identify our x values first. Now, just be careful here. They use different variables. So instead of using y, they use p. And instead of using x, they use t here. So we're going to write down our domain would be, okay, so which x values are allowed? Well, first of all, my x values have to be greater than or equal to -2. So I'm going to draw my little squiggly bracket, and I'm going to say x is greater than or equal to -2. And then what's my upper limit? Okay, all x values must be less than or equal to 4. So we can write down x is less than or equal to +4. And if we're in this little area here from -2 to +4, what kind of x values are allowed? All of them. Okay, all real numbers are allowed as long as you're between -2 and +4. So we'll close that off. How about the range? Okay, so the range is a list of all possible y values. So the lowest y value you would have would be -3, and the biggest y value you would have would be +1. So if I write down the range, okay, we can say, first of all, y must be a number that is greater than or equal to -3, and it must be less than or equal to, what's the biggest y value you can have? +1. Oh, I need to use the correct variables. So let's change this. So this should actually be, well, first of all, yeah, let's just fix this right now. Okay, not y. We want to use p. So we'll say p must be greater than or equal to -3 and less than or equal to +1. And in that range here, p can be any real number, as long as it's between -3 and +1. And then for the domain, let's just fix it because the variable is t, not x. So we've got t. So t is greater than or equal to -2 and less than or equal to +4. And in that area, t can be any real number. Okay, we've got this weird mapping diagram. I find the best way maybe to interpret a mapping diagram is just to, if you want, you can write it down as like ordered pairs. But really what a mapping diagram does is this oval on the left-hand side, that shows you all x values that you would have if you wrote down an ordered pair. And this oval on the right-hand side would be all the different y values. Now, if you want to write all the different ordered pairs from this mapping diagram, what I would do is 1 can go to, so when x is 1, y can be -2. So you'd have like 1, comma, 2, not -2. 1 and 2. And when x is 1, you could also have y is 6. So we could write down y, comma, 1, comma 6. 2. So if x is 2, then y could be either +2 if you go up to the top, or it could be +6 if you go down to the bottom. So you could also have 2, comma, +6. and here, 3. So if x is 3, there's only one spot the arrow goes to, and that's going to be y is equal to 6. Now, if you wanted to, you could look at the ordered pairs and write the domain and range like that, but it's actually much easier just to use the mapping diagram, because the mapping diagram shows you the only possible x values. Therefore, for my domain, it would be d would be equal to. Now, because the graph isn't continuous here, it's just like specific points, we can just identify the domain by listing the x values. So the possible x values you have are 1, 2, and 3. And then for your range, just look at the second oval, because the second oval in the mapping diagram shows all possible y values. So you'd have range would be just 2 and 6. D says a circle that has a center of -2, 3 and a radius of 3. All right, we're going to have to sketch a picture to see what this looks like. So I'm just going to sketch a mini Cartesian plane. Okay, so there's my y-axis, and we'll do the x-axis about right here. Okay, I'll just draw some grid lines on here. So let's say that we have 1, 2, 3, 4, 5, 6, 7. We'll do 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, let's try to plot this thing. So it says the center of the circle is at -2, +3. So that'd be 2 to the left and then 3 up. So the center of my circle is going to be located at this position. Now, the radius of the circle is 3. So the radius just means the distance from the center of the circle to one of the outer edges. So I'll show 3 outer edge points. Okay, I'll show like the outer left, the outer right, the outer top portion, and the outer bottom portion. So if we start at the center and go radius of 3 units down, we go 1, 2, 3, and then we'd actually have the bottom of my circle is going to be on the x-axis. If we start at the center of the circle and go radius of 3 units up, we go 1, 2, 3. So I'd be all the way up here. Okay, that's going to be the top of my circle. I'm going to sketch in a second. If we start at -2, 3 and do a radius of 3 towards the right, we'd go 1, 2, 3. So we'd be located right here. That's going to be the right side of the circle. And then if I start at -2, 3 and I go to the left, I would go 1, 2, 3 over. So this is going to represent the left-hand side. Now to sketch the circle, I'll just connect these points on the outside and try to make a circle as best I can go through it, which actually that's better than I thought I was going to be able to do. Okay, now let's identify the domain and the range. Okay, so the domain is the list of all possible x values. So again, the easiest way to do this is identify what's the lowest x value you have and what's the biggest x value you have. So if you start at the edge of the circle and you just go straight down here, the lowest x value you would have would be at 1, 2, 3, 4, -5. Okay, so all x values must be greater than or equal to -5. What's the biggest the x values can get? +1. Therefore, all x values must be less than or equal to +1. And between -5 and +1, what kind of x values are allowed? All of them. So we could say x is any real number. Okay, how about the range? So the range is all possible y values. So I'd look at your smallest y value you could have, which would be at the bottom of the circle here. Your y value would be equal to 0. Therefore, I'd write down range would be equal to y must be greater than or equal to the bottom of the circle in terms of y values, so greater than or equal to 0. And then the top here this is where we have 1, 2, 3, 4, 5, 6. So the y value at the top of the circle will be y equals 6. Therefore, all y values must be smaller than or equal to positive 6. And in this range, from 0 to positive 6, what can the y values be? They can be anything, okay? All real numbers, as long as they're between 0 and positive 6. Okay, example 4 says draw the graph of a relation that has a domain of x as any real number. So what that means is when we draw the graph, like the graph must be continuous both towards the left and the right. And the range is, so what it shows right here, the symbol looks kind of weird. So it says like y, then you have like this vertical line. I'm just going to focus on this part right here. It's just a different way you can actually write down what the range is. You can write down the variable and then a vertical slash, and then you can write down the actual range like we've been doing before. But anyways, let's just focus on what's boxed there. We can write that alternate notation in a different lesson. Okay, so all x values are allowed, but y cannot be bigger than 2. Okay, y values must be less than or equal to 2. Now it says draw a graph of this that would only have one x-intercept. Okay, so let's just sketch a mini Cartesian plane. Okay, y, x, and I know for sure the x values cannot be bigger than 2. Or sorry, the y values cannot be bigger than 2. So what could one graph of this look like? There's lots of different ways you could sketch this, but basically, I would need the graph to be, it can't be bigger than 2, and it only has one x-intercept, so maybe the line could go down here like this. Okay, so let's check to see if this makes sense. So y is less than or equal to 2. Yes, it is. Okay. Does it have one x-intercept? Yes. Have I shown all x values can exist? No, because I have to show the graph going all the way towards the left as well. Now, I don't want this graph to cross the y-axis another time, so maybe what I could do is I could just sketch a graph where it goes towards the left here. Now this should make sense, okay? Are all x values allowed? Yes, because the graph goes all the way to the left, all the way to the right. And are all y values less than or equal to positive 2? Yeah, they start at positive 2 and they go straight down. Okay, how about if we have two x-intercepts? So we have my y-axis, my x-axis, we have 1, we have 2. I'm going to use a curve or a parabola shape to do this. So basically I can start here. The graph cannot go anything higher than that. And then I'm going to have a curve that kind of like goes up and then goes back down. The top of this curve right here is 2. Okay, and I'm going to show it go off. Okay, put the arrows here that indicate the graph keeps going down and towards the left, like infinitely. And this arrow, same as well, just means the graph goes down and towards the right for infinity. So because the graph goes to the left for infinity and to the right for infinity, the domain is any real number, and the range is less than or equal to positive 2, and I have two x-intercepts, 2 spots where it hits that. Okay, B says, explain why it is not possible to draw a graph which has an infinite domain, so all x values are allowed, and a range that is less than or equal to positive 2, but no x-intercepts. Okay, so let's just sketch a little graph here. Okay, so my y values need to be less than or equal to positive 2. Okay, all y values that are less than this. So here's the issue. If your domain has to be all y values less than negative 2, So maybe we could just draw a graph here and start going down. The problem is, in order to have like all the y values here, so here's like all the y values below the graph, the only way that can possibly happen is if your graph would cross the x-axis. But we've been told it has no x-intercept, so that's impossible. Okay. If your range as y is less than or equal to +2, okay, so +2 being up here, and it has to include everything below that, then the only way you can include that would be if your graph would cross the x-axis at least once. But since we're saying right here, there's no x-intercept, it's actually not possible to draw that graph. All right, let's apply this to a word problem. So it says a high school football team is hosting a banquet to celebrate winning the championship. The caterer charges a setup fee of $500 plus $20 per person. The equation C is equal to 500 plus 20 yen represents the cost of hosting the banquet for n number of people. Make a table of values with 8 entries for a minimum of 100 and a maximum of 500 people. Okay, sure. Okay, so let's start off with, it says it wants me to have a minimum. So n is a number of people at the banquet, so a minimum of 100. And then it wants me to go up to a maximum of 500 people. So let's just go up by like 50s. So we'll go 100, 150, 200, 250, 300, 350, 400, 450, and it wants me to stop at 500. Well, in order to do that, I need to have like 9 entries. So I'm just going to, even though it tells me to do it for 8 entries, I'm going to do 9. Okay, and it wants me to create a table of values. So I have all these input values here. And the cost is going to represent my outputs. So the way to get the output values is we're just going to take the equation, which is C is equal to 500 plus 20 times n. And what I'm going to do is I'm just going to substitute different values of n into the equation. So we'll start off by plugging in n equals 100. So we'll replace n here with 100. So that would be C is equal to 500 plus 20. Again, anytime you substitute something in, just put it in brackets. So that would be times 100. 500 plus 20 times 100 would be 2,000. So that should be 2,500. Then let's do n is equal to 150. I guess we can write that on the table right now. So plug that into the equation. C would be equal to 500 plus 20 times, this time we're going to plug in 150. 20 times 150, I think, is 3,000. So this should actually be 3,500. And then n is equal to 200. Plug that into the equation. So we'd have C is equal to 500 plus 20 multiplied by 200. 200 times 20 would be 4,000. 4,000 plus 500 would be 4,500. And now what you should do is since we've done 3 table entries, to see if we observe a pattern. Okay, so as n increases by 50 people, the banquet, the cost keeps increasing by 1,000. So I see this constant number that's increasing by. Therefore, I can fill in the table just by identifying the pattern. For every 50 more people that come to the banquet, the cost is going to go up by $1,000. So this one would be 5,500. This one would be 6,500. This would be 7,500. This would be 8,500. This would be 9,500. And this would be 10,500. All right, there's my table of values. Now B wants me to plot this data on the graph. Okay, well, let's give a title first of all. So let's call this the football banquet. Okay, the y-axis. So we go back up to our table. Whenever we do a table, we always have our manipulated variable first and your responding variable second. Therefore, we're going to use n as the x-axis, and we're going to use capital C as the y-axis. We can actually label this graph a bit better, but I think for now, just it's okay. This is Physics 20. I would want you to do like much more thorough labeling of the graph, but anyways, it's not Physics 20. Okay, let's plot these points. Okay, so well, we need a scale first. So the biggest, the greatest number of people I think we have is all the way up to 500. So what I'm going to do is I'm going to make every 5 grid lines, every major grid line go up by 100. So you have 0, 100, 200, 300, 400, and then 500. Okay, and then the cost, the biggest number we have is you go up to 10,500. So what I'm going to do is every 5 grid lines, I'm going to go up by 2,000. You might use a slightly different scale, but this one works okay. 2,000, 4,000, 6,000, 8,000, 12,000, or 10,000. And at the very top here, let's actually move the C a little bit higher, just so we can scale the graph. So we'd have 12,000. Let me write down the C here. Okay, let's plot these points now that we have a scale. So the first point is when if there's 100 people at the banquet, the cost is 2,500. So at 100, 2,500 would be, okay, 3,000 would be halfway between 2,000 and 4,000. So 3,000 is probably somewhere about right here. Okay, then the next point is 150 and 3,500. So 150 is halfway between 100 and 200. And then we've got 3,500. So 3,000 is halfway between 4,000 and 2,000. Then have that, and we're probably about like right about here. There might be a better scale you can use in this, but this is sufficient. Okay, then we've got if there's 200 people, the cost is 4,500. So 200, 4,500 is probably going to be about right here. Then if there's 250 people, the cost is 5,500. So that's going to be about right here. If we have 300 people, the cost is 6,500. So that's going to be about right here. And then if we have 350 people, it's $7,500 cost. So that's about up here. If we have 400 people, it's going to be 8,500. So that's going to be about right here. Then the final point, if we have, we need 4,500 first. If we have, 450 people, then we have 9,500. So 450, 9,500 is about here. And then if we have 500 people, the cost is 10,500. So that's going to be located about right there. Okay, so we did that. Plot the 8 ordered pairs from the graph. Okay, now it says, if all possible ordered pairs from B were plotted on the grid, state the domain and range of the relation and explain why there are restrictions on both. Okay, let's go back up to the problem here and just identify what it says. Okay, so no matter what you do, even if you had like 0 people attending, the caterer is going to charge $500 no matter what. So on my graph, it doesn't make any sense to draw a line of best fit where you would have the cost that's less than 500. So if I'm going to draw a line of best fit on this graph, let's just find a line here. Okay, so 500, I think, would be located. Oh, no, but they told us here, they said that the banquet has to have a minimum of 100 people, okay? Yeah, it says here we need to have a minimum of 100 people, and we have to have a maximum of 500 people. Okay, so that's going to help me in drawing a line here in a second, okay? So I'll just write this down. So your minimum is n is equal to 100 people. I can't spell. Minimum. Minimum. There we go. And a maximum of n is equal to 500. So when I draw a line of best fit through this, so now I'll go with the line. Okay, I'm going to start my line of best fit at n equals 100 people, and then I'm going to go up. So we'll start here, and we'll draw the line of best fit through. So it goes through like this. I don't want to draw the line of best fit to the left here because they flat out told me in the question that we're not doing this banquet unless you have a minimum of 100 people. So there's no point of actually doing that. Okay, now let's identify the domain and the range. Okay, so the domain is all of your possible x or n values. Okay, we'll use n here. Okay, so let's do squiggly bracket. Now, we've already identified what our restriction is. So n has to be greater than or equal to 100. And n must also be less than or equal to 500. Now, what kind of n values make sense here? So this is where it gets a bit iffy because you might be saying, okay, what n is any real number, but that's not true because if n is any real number, then you could have, like, for example, 100.5. You can't have 100.5 people attending the banquet. It's got to be a whole number. So what I'm going to say here is n is any natural number. So natural number are all of your positive whole numbers because the number of people at a banquet must be a positive number. Okay, how about the range? So again, the easiest way to do this is to identify what's the lowest y value you can have and what's the biggest y value you can have, the easiest way to identify this is look at the table, okay? So if you have 100 people, the lowest cost you would have would be $2,500. And if you have the maximum number of people, your highest cost would be 10,500 people. Okay, so my y values must be bigger than 2,500 and they must be less than or equal to 10,500. So when I write the range out, I'm going to write down the range must be your cost has to be greater than or equal to the number of people that would attend. The cost if only 100 people attended, so that would be 2,500. And it must be less than or equal to that maximum cost, which is 10,500. So it's got to be less than or equal to 10,500. Okay, now what about the restriction on the cost? So as long as we're within this range, what kind of values can we have? Are we allowed to have like any number? Like could I have a cost of like $4,321.22? Yeah, sure you can. So I'll say it's any real number. Obviously, there's a restriction to this because typically you only write down cost in dollars, the nearest hundredth of a decimal place. But we'll just say that the real numbers to incorporate dealing with some of those decimal numbers. All right. So that's it. So again, your domain is a way of you listing all of your possible X values. Your range is a way of listing all of the possible Y values for a given relationship or a graph. Okay, you can practice this by doing page 426, numbers 1 through 8, all parts, except just omit number 3. And I'll talk to you in the next lesson.